I was talking and then I suddenly realized that my audio was muted. Sorry. So how are you, everyone? Good. So assalamu alaikum to all of my Muslim students and hello to everyone. Thank you for being online for one more session. Next week, Wednesday, also you're going to have another online session. And surprisingly, in your exam, when I asked you who would prefer both in person, only 3 of you said you would like to be both in person. And 3 of you recommended or want to have the class in person instead of one day online, one day in person. So I actually cannot have both classes online because originally this class was meant to be in person. So the 3 of you who want to have the original setting, then I cannot go against that rule. Oh, it's configured to microphone? Oh, I'm sorry. Let me see. How about now? Is it okay now?
It's good.
Thank you. But yeah, because I logged in from 2 computers. That's why I didn't realize. One of them wasn't muted. The other one was muted. Yeah. Okay, so I was saying, since 3 of you disagree to be on stay in online, what I'm saying, to be on stay online. So after March 19, we are going to have for a few weeks all in-person classes. And then the 3 of you, if you want to change your mind and want to have online Wednesdays, then we can go back to online Wednesdays. Okay. So I was actually happy that almost all of you, from 35 of you, 2 students or 1 student didn't take the exam. 1 student didn't take the exam. So from 34, so I will say 30 of you. 30 of you decided to or would like to have online Wednesdays. Thank you. I also like to have online Wednesdays. But our priority is the people who want to have both in person. So I have to respect that, unfortunately. Okay. So after next week, we are going to have both in-person classes at least for a few weeks until they change their mind. If they do not, then sometimes we will have online classes, sometimes, but not fixed every Wednesday. Okay? It will not be a fixed date. It will be sometimes. Okay. Any question, comments, concern, complaint? Nothing yet. So I actually graded your homework 2, 3, 4, and I'm on grading your last homework, except for Rahmanjan. I have your file separately, so I have to look at that, and then I'm going to post your grade. Besides him, for everyone else, if you posted your solution, then you have your score. And yes, Rahmanjan, we cannot have online Wednesdays after next week. Yeah, I know. But we have to respect their choices. The other homework, so we are on chapter 2. I'm going to post 2.1 homework. and we will be finishing 2.1 today. So you have 2.1 due next week. Instead of Monday, I'll give you time till Wednesday, 1 week. Yes, this will be homework 6 on 2.1. And if we finish 2.2 today, then also you're going to have another homework. But most likely we won't be able to finish that today. And about homework, I should mention something. Every semester, at least one student, they never show any work. What they do is the question I post, they scribbles their answers there and assume that I should read through all the tiny details they wrote on the homework sheet. It's really hard for my eyes. So I'll recommend please do not do that. One of you I noticed, I forgot who, but always one of you give me a homework not written on a separate paper, but on the tiny homework sheet that I post. Please do not do that. Think about my eyes, how much it hurts when I grade those tiny thingy. Plus, there are no details. I want to see all the details so that I actually know the process. And why do I care? Well, because you need them. Most of you are computer major, right? Some type of computer. So you actually need these materials later in your life. Um, so why not learn it instead of just passing this class? So I wrote comments on actual submitted homework for most of you, and for a few of you, I comment on the comment box on the submission tab. So if I'll say look through your solution, what you posted. If you have anything wrong, you see what I wrote there. And if you don't see anything I wrote, but you get taken points and you wonder why I didn't give you full points, you can contact me. I'll tell you why I didn't give you full points. Usually, I notice that most of you did homework perfectly as I expected. So thank you so much for doing that. It's for your own good. If you follow my direction, you will get benefit from that, not me. While I will get benefit, my eyes will hurt less. So I'll grade them with pleasure. And also at the beginning of the semester in the syllabus, I said I'll be harsh grading on the exam. But for the last few exams, I actually was very generous grading them. That's because I didn't post any solution. Usually I post solution. But this semester was a really, really hectic semester for me because I had a very important exam, my certification exam. So I was studying for it real hard and I didn't have time to think about anything else that much. So that's why I forgot to post the solutions for all those homework. And at least if you see solution for one, you could do better in the next one, but you didn't have that chance. So that's why I graded them very generously. But my plan from onward, after the due date, to post the solution for the questions out of the homework. And also, I really wanted to post the solution for the review sheet, but I completely forgot until the exam day when someone told me there was no solution for the review sheet. I was like, damn, I had the solution, but I totally forgot to post it. See? So far, I wasn't a very good instructor for you guys, but I'm determined to improve myself from now on. After Ramadan, okay? In Ramadan, I don't have time. So after Ramadan, I'll improve myself, which is after next Wednesday, and I'll try to give you all the solutions for every homework. And for the next review sheet, I will start making it so you can see it soon. Oh, and so today is 11, and let me see the calendar. We have our spring break from April 1st, so we have next week and then the following week, so 2 weeks. After 2 weeks, we are going to have 3 days off, which is another 2 weeks. So probably I'll make the review sheet on that week. And our next exam will be middle of April or end of April. End of April. Middle of April doesn't make sense. Probably 27 or 29. So I have enough time to grade them before our final. Yeah. So end of April will be our next exam. And our break will be from April 1 to April 9 or something. 9 or 10, I forgot. But we are going to have 3 days off, I believe. So I'll make the review sheet there at that time. And let's see how much we finish before that. Our exam will be up to that point. Up to that point with those materials. Okay. Question? Comment? Good. Thank you, Jonathan. Okay, so let me refresh your memory what we did in our last class. In person, we started chapter 2. So if I noticed a few of you are absent in our last in-person class, which is last Monday. So if you are absent, I hope you watched the recording for last Monday. If you haven't, then you might feel a little lost. But I'll refresh a few materials, not in details, but briefly. So we started determinant, and we talked about determinant for 2 by 2 and 3 by 3. And we said if we have a 2 by 2 matrix, AB row-wise and CD row-wise, then our determinant is the main diagonal minus the anti-diagonal. So we multiply all the elements on the main diagonal, which is A times D, and we subtract the product of the anti-diagonal, which is B times C. So AD minus BC is our determinant. And to get inverse, we switch position for A and B. We change sign for B and C. After I do that, we divide every element by the determinant we found. And you're supposed to show me this in the last exam. So I didn't look at the exam yet, but I'll see. How did you guys do? So 2 by 2 is simple. It's not very difficult. When we have 3 by 3, then our life becomes a little difficult. Why? Because 3 by 3 has many different ways of finding determinant, and also a few ways of finding inverse. So to find the determinant of 3 by 3, we can follow the same rule as the 2 by 2, but then we have to do something a little bit extra to do what we did for 2 by 2. What that extra thing is, we rewrite our first 2 columns next to the third column. So if you have a matrix ABC row-wise, DEF row-wise, GHI row-wise, then we need to write the first column, which is A, D, G, and the second column, B, E, H, next to the third column. Why do you do that? Because when you do that, we can find all the diagonals, the main diagonal, also the anti-diagonal. So to follow the 2 by 2 method, we need to find the product of the elements of the main diagonal. So we multiply all the elements, all 3 elements in the main diagonal, and then do the same thing for the next diagonal, then for the next diagonal. So for every main diagonal, the product of the element of the main diagonal, we add with one another. So the product of the first diagonal plus the product of the second diagonal plus the product of the third diagonal. So every main diagonal, we add their product of the elements, and then we subtract the product of the elements of every anti-diagonal. So for anti-diagonal, we have CEG, that's our first anti-diagonal. Then our second anti-diagonal is this one, and then this is our third anti-diagonal. For every anti-diagonal, we subtract their product. For every main diagonal, we add the result, and for every anti-diagonal, we subtract. Whatever we get, that's our determinant. So this is one of the easiest method of finding determinant for 3 by 3. But this is not the only method. We have another method, which is the normal method. It's called cofactor expansion. In cofactor expansion, we take one element. So if we have A, B, C, D, E, F, G, H, I, A, B, C, A, B, C, D, E, F, G, H, I, C, D, E, F, G, H, I. So if we have A, B, C, D, E, F, G, H, I as our matrix, then you first decide how do you want to expand your matrix. So you decide one row or one column. So here they decided to use the first row. So once you decide, you take the first element in the first row and then cross out the entire rest of the row and entire rest of the column. So if you cross them out, you're left to a tiny 2 by 2 matrix. We call them minor. So this is a minor for the position 1, 1. Then you multiply the position 1, 1 element with the determinant of your minor. And then you subtract the next element in your row. The next element in the row is B. So you keep your B and you cancel out everything else on the second column and first row. Once you cancel them out, you're left with another tiny 2 by 2 minor. And this minor is for the position row 1, column 2. So you multiply the determinant of 2 by 2 minor matrix by the position, the element you have in the position 1, 2. And you always have to subtract this position. Then you move on to the third position on your row, which is C. So when you select C, you're going to add this position, but you're going to cancel out everything else in that row or in that column. So you're going to ignore the entire row and entire column. So you're left to the tiny 2 by 2, another minor, and that minor is for the position row 1, column 3. So for 1/3 position, you have a minor on the left side. You take the determinant of that minor, you multiply by the position in the C. And you do it for every element in your row or every element in your column. So you're going to do only one row or one column, and you can decide which one you want to do. And then once you add, subtract, multiply all these things, whatever you get, that's your determinant. And this method will work for every type of element, 2 by 2. I mean, not 2 by 2, sorry. 3 by 3, 4 by 4, 5 by 5, 6 by 6, for everything. But the first method I showed you, the main diagonal minus left diagonal, this is only for 3 by 3 matrix. So this diagonal will not gonna work for 4 by 4 or 5 by 5. It will work only for 3 by 3. So this method is specifically for 3 by 3, but the cofactor expansion, it's true for any type of matrix, any square matrix. So these are the two types we learned. And then we talked about there are a few shortcuts for the determinant based on what type of matrix you have. If you have a matrix that has one entire row or entire column full of zeros, then your determinant is automatically 0. You don't have to show any work, you don't have to do any math, it's automatically 0. Or if you have a matrix that has two same rows or two same columns, then your determinant is 0. No math is needed. And then we had another good matrix. If you have a triangular matrix, either upper triangular or lower triangular, any type of triangular matrix, or any type of diagonal matrix, sorry, not any type, any diagonal matrix or any type of triangular matrix, then the determinant is the product of the diagonal elements. So if you have A, B, C, 0, D, E, 0, 0, F. So this is an upper triangular matrix. And we have our diagonal is here, the main diagonal. So this matrix has a determinant ADF. Or if you have a lower triangular, A, B, C, 0, D, E, 0, 0, F. This is a lower triangular matrix. So we have a main diagonal ADF. So our determinant is ADF. And if you observe in both lower and upper triangular, we have our main diagonal. So the determinant is the product. Now there is another scenario. What if you have something in the entire diagonal? So a type of matrix that doesn't have main diagonal, but it has entire diagonal. For example, if we have something like A, B, C, no, A, B, C, oh no, 0, 0, 0, A, B, C, D, E, F. So we have 0 on the above of your entire diagonal position. So this is not actually a lower triangular matrix. The lower triangular matrix is this one, and upper triangular matrix is this one. So whatever you have here, it's an entire lower triangular, because the normal one are these two. These are normal. So if you don't have these two, that means whatever you have, they're not normal. They're entire the original normal thingy. So if you have this type of matrix where you don't have the normal lower triangular or normal upper triangular, in other words, if you observe the diagonal and it gives you if it gives you something on the entire diagonal position, so your determinant is still the product of all the elements in the entire diagonal, but for 3 by 3, you need to change the sign of your determinant. This is not true for 4 by 4. This is true for 3 by 3. And I'm going to show you later for which matrix you have to change the sign if you have anti-diagonal entries to multiply. So we learned all this in our last class. That was the main idea. And now we are going to learn how to find the inverse of 3 by 3. So finding inverse, again, there are two methods. One is informal and one is formal. In the informal method, so if you have a matrix A, B, C, D, E, F, G, H, I, in this informal method, we are going to rewrite the first two columns next to the third column and first two row below the last row. So from a tiny 3 by 3 matrix, we get a big 5 by 5 matrix. And then you have to find the determinant anyway. You always have to find determinant to find the inverse. So find the determinant either using the anti-diagonal and diagonal, the first method, or the cofactor expansion. Anyhow, find your determinant. And once you have a determinant, you need to multiply a new matrix. That matrix, we call them, what do you call them? We call them Adjugate matrix. So what is Adjugate matrix? It's the transpose of whatever you originally have of your cofactors, all the minors. So what we do is once you rewrite the first row on the right side and first two column below the third one, then you cross out the first row and first column. So instead of having a 5 by 4, you actually end up getting a 4 by 4 matrix. And then you go either row wise or column wise, and you find determinant for every 2 by 2 cofactors or every 2 by 2 minors. So let's do an example. Things will be easier. We have a matrix 1, 2, 3, 4, 5, 6, and then 1 to 1. Now we have to find the inverse of this. To find the inverse, first we need to know its determinant. So to find the determinant, we are going to rewrite the first two columns next to the third column. So 1, 4, 1, and then 3, 6, 1. Once we do that, then we go ahead and find diagonal, the main diagonal, and anti-diagonal. So the main diagonals are 1, 5, 1, that's 5, plus 2, 6, 1, that's 12. And then we have 3, 4, 1, that's another 12. So we have 5 plus 12 plus 12. These are the main diagonal. Did I make a mistake? Oh man, thank you, thank you, thank you. I did make a mistake. 1, 4, 1, and 2, 5, 2. Thank you for getting that. I'm so glad you guys are attentive. So that means I had to change my numbers. So we have 1, 5, 1 is 5, 2, 6, 1 is 12, and then we have 3, 4, 2. So 12 plus 12 times 2, 24. Right? 4 times 6, 12, 12 times 6, 24. So we have these are our main diagonals. Every main diagonal entries, you add them. And then you go to the anti-diagonals. Our first anti-diagonal is 1, 5, 3. So 3 times 5, 15. The next one is 2, 6, 1, which is 12. And then we have 1, 4, 2, which is 8. So we subtract every anti-diagonal. You add every main diagonal and you subtract every anti-diagonal. 15, 12, and 8. So 12, 12 cancel out. We have 5, 15 is negative 10, and 24, 8, 16. So 6. Right? Did I make a mistake anywhere? 16, 8, 24. 15, 5 is 10. Then 16, 6, 16, 10 is 6. Let me know if I make more mistakes. So this is our determinant. Once you know determinant, now we need the new adjugate matrix. To find the new adjugate matrix, what we do is we are going to rewrite the first two row below the third row. So we have 1, 2, 3, 1, 2, 4, 5, 6, 4, 5. And let me erase my ink because we need to use this. Once you write the first row and the first column, then you cancel out the entire first row and entire first column. We don't need them. These are useless. And now we have a 4 by 4. So for 4 by 4, our A inverse will be 1 over 6. And then you're going to go every 2 by 2 matrix. So first 2 by 2 matrix is this one. We get 5 times 1, 5. Minus 6 times 2, 12. So we get negative 7. And then our next 2 by 2 matrix is this one. So do the same thing. 3 times 2 is 6. But since I'm going column-wise, the result I have to write row-wise. So if you go in one direction, the result you have to write in the other direction. That's why it's called transpose of cofactors. So I'm going column-wise. We have 3 times 2, 6. But I'm going to write row-wise. 3 times 2, 6 here, minus 2 times 1, 2. That gives us 4. And then the next 2 by 2 is here. So for this 2 by 2, we have 2 times 6, 12, minus 3 times 5, 15. So that gives us negative 3. Okay. Then we go to the next 2 by 2. So we are done with our column. So the first 2 column, it gives us the first row in our Adjugate matrix. So we go to the next 2 column. Our next 2 column, let me highlight them, is this 2 column. So for this 2 column, we are going to do the same thing. We take every 2 by 2. Since I'm going column wise, I have to write the answer down row wise. So let me pick green. The first 2 by 2 is here. 6 times 1 is 6, minus 4 times 1 is 4. 6 minus 4 gives us 2. Then we have the next one. 1 by 1 is 1. And we are subtracting 3 times 1, which is 3. That gives us negative 2. The next one is 3 by 4. So 3 times 4, 12. And we are subtracting 6 times 1. That gives us 6. The answer is 6. So we are done with the next 2 columns that gave us our second row. And now lastly, we have these 2 columns. So these 2 columns are going to give us our third row of the Adjugate matrix. So let me take blue. We have the first one is 4 times 2, 8. And we are subtracting 5 times 1, 5. 5 minus 8 minus 5 is 3. The next one is 1 times 2, 2. And then 1 times 2, 2. That gives us 0. And lastly, we have 1 times 5, which is 5. And we are subtracting 4 times 2, which is 8. 5 minus 8 is negative 3. And we are almost done. So our A inverse is negative 7 over 6, 4 over 6, negative 3 over 6. The second row is 2 over 6, negative 2 over 6, and 6 over 6. Then the third one is 3 over 6, 0 over 6, negative 3 over 6, and then we reduce. So our final answer is negative 7 over 6, 2/3, negative 1/2. Then 1/3, negative 1/3, 1. We have 1/2, 0, and negative 1/2. This is our final result for the inverse. And yep, in your next exam, you have to do one of these. You need to find the inverse of a 3 by 3 matrix in your next exam. So you definitely need to know how to do this manually. Any question? Any question from anyone? No question. Are you guys sure there are no questions? So this is the shortcut method, okay? It's not the formal method. Let me introduce you to the formal method, and then it's too much for the first time. But if you keep doing it, then it should be easy. You can do it in probably 3 minutes if you practice them a little bit. It does look tedious, that's true, because I am showing the work and you're observing. But if you do the work for several times, it definitely will be much cleaner and much faster. Okay, so you have 2 questions to try now, but before that, let me show you the second formal method. The second formal method, you do the exact same 2 things, but instead of rewriting the way I wrote the first 2 rows and first 2 columns, you just write every 2 by 2 matrix. You write them manually, like really write them, and then find the determinant, which is the exact same thing as what we did, but here they are talking about the position, what position you have for the uh, for your um, for your Adjugate matrix, and also you have to remember the sign. The first one is plus, the second one is minus, then plus, minus, plus, minus, plus, minus, plus. So remember the position and the 2 by 2 matrix you are working with. I find this cofactor expansion is much harder. Not harder, like confusing. Unfortunately, this is the method I learned. When I learned this thing, I never knew about the method I just taught you. So when I learned about the method I just taught you, it's like, cool. It's really wonderful that I don't have to keep remembering all these positions' name and their sign. So if you learned about this formal method already and you like it, feel free to use it. But you don't have to do that. You can simply use the method I just taught you. So now you have 2 of these to try. Do you guys need to see the process here, the steps here to do them? If you need it, take a screenshot so that you can use these things, this direction to find the inverse for. Before that, one question. Who knows the answer? Uh, what is a singular matrix? What is a singular matrix? Or what type of matrix is a singular matrix? Get down. The matrix that doesn't have any inverse. What type of matrix doesn't have inverse? Don't tell me singular. Like, without using the word singular. How do you know whether... Get down. You get the idea. It has to be square, and the determinant cannot be 0. So if you have a square matrix with determinant 0, even this is a square matrix, but the inverse still doesn't exist. So go ahead. You need this information to enjoy these next 2 matrices. So find their inverses if possible. If not possible, tell us why it's not possible. Okay? I'll give you 45. I'll give you 10 minutes. So 55, at 55, we're going to discuss these 2. So enjoy, and let me take the attendance now. And you really need to know this, guys. So you should really try this now. And with this, we'll be done with 2.1. So your homework for 2.1 will be next week, Wednesday, midnight. Okay, so today is 3/11. Ahmed, are you still there?
Yeah, I'm here.
Thank you. Crystal,
Here.
Christian,
Here.
Daniel, Eric, Eric, are you there? Florence, absent. Franklin, absent. Gassan,
Here.
Halil, Halil. Oh, Eric, you are here. Okay. Halil. Okay. Imran,
Here.
Jackie,
Here.
Jerry. Okay. Jonathan, are you still there? Great. One Tavarij. Sorry, Tavar. One absent. Julian here. Karma, no Karma. Kate. Okay. Kathy. Man, are you there? Man,
Hello?
Eric.
Yeah, hello. I'm sorry. On mobile, it wasn't letting me unmute. But I'm
Okay,
here.
I got you.
Thank you.
Man is here. Matthew. No, Matthew. Melissa here. Mohammed, are you still there?
Yeah, I'm here.
Okay. Monata. Omar C. Omar D. Great. Prabhat.
Here.
Rahmanjan, are you still there?
Here.
Ryan. Rayat. Rayat absent. Wow. Sadia Sattar. Sadia Sattar. Sadia Sheikh. Sadia Sheikh. Come on, guys. Sam. Soraya.
Here.
Saima. Stephanie. And lastly, Valerie.
Here.
Great. So let's see whom I marked absent. Florence, absent. Franklin, absent. One, absent. Karma, absent. Matthew, absent. Rayat, absent for the first time. Sadia Sattar, absent. Sadia Sheikh, absent. and Stephanie absent. So if I have 26, 7, 8, 9, 31, 2, 3, 4, 5. Oh, so many absences. So how you guys are doing? Any comments so far? I believe you guys should be able to do the first one at least. Or you should be done with the first one already. Right? So only Ahmed responded. How about others, guys? Are you guys at least done with A? I'll give you 5 more minutes for B. Let me know if any of you need to ask me any question for any step or for any information. Mm. 2 more minutes. A few days ago, I read a news about a Korean actress, I think. Yeah, Halil, I already called your name, but I marked you absent. Sorry, here now. You sure you're here? Halil, Halil. Okay, I marked you present now. So what I was saying, I was reading a news about a Korean actress. I think it's Korean actress, Korean or Japanese, some type of actress. She bought a bag, a handbag with $15,000 or something. And do you know what bag that was? $15,000 or 1,000, 1,500. I forgot, but it's a big amount. And the bag I looked at I was completely shocked. Like, really? Can you guess what type of bag she bought? She bought a plastic bag. The bag we used to get in the groceries. Like that same type of plastic bag. And I don't know why, with what or by what materials it was made of. The cost for that bag was huge amount. And I was thinking, like, we have lots of plastic bags lying around in our house or everywhere in New York City. She had to buy a bag, a handbag. It's a handbag, even it's a plastic bag, but it's a handbag worth that much money. Like, I was thinking, how stupid people can be. Like, come on, not even leather. Exactly. If it was a brand name bag, I understand. But it looks exactly like a plastic bag. And it was made of some type of plastic. I don't know what type of plastic bag. Exactly. And then there was one picture. I don't know what is true or false, but one guy he posted a banana on the wall, and that picture worth so much money suddenly. Like people are getting crazier day by day. They want to spend money on some worthless thing. Like that is totally normal for our case. Go to Korea. I think she's a Korean actress. I watch all sort of things. I watch Chinese, Japanese, Korean, anything that has subtitle and good story. I watch those. I love watching animes, especially animes. But if it's a good story with a drama, then I also like watching good dramas. So I was like, oh man, like we get free plastic bag. I mean, we used to get free plastic bag. Not anymore. Not at least not in the store. But anyway, so even if you do have lots of money, don't be stupid, guys. That's the bottom line. Give it to some poor people. Donate it. At least you get some good deeds written on your good deed list. But spending so much money on just a plastic bag and using it as a handbag. Ah. Okay, anyway, who is ready for A? Volunteer for A. Ahmed.
Um, sorry. This has no inverse
How do you know?
because determinant will be zero
Determinant is zero.
because
Why
rows
or how the determinant is zero?
because rows 2 and 3 are equal. So it would end up being
Uh-huh.
zero.
We don't even have to find the determinant using the determinant rules. We can see clearly the first row and the second row and the third row are same. So automatically the determinant is zero. And if the determinant is zero, please don't do that. I hate that. Let me save it. If the determinant is zero, we automatically get no inverse. So in the exam, I'm going to test you with one of these. Okay? So make
This
sure don't
will
fall for it. Huh?
this will columns being equal will be the same too, right?
Exactly. Same
Okay.
two columns or same two rows. Either one of them will give you determinant zero. Or if you have one entire row, or entire column is 0, the determinant is automatically 0. Can I write now? Okay, I can. Okay, thank you, Ahmed. Volunteer for the next one. Who would like to give me the determinant for the next one? B. Mohammed.
I got the determinant -26.
-26. So let's see. Did you use the cofactor method or did you write the first column next to the third column? Which method?
The first one we used that one.
Okay. So we have 1. What is happening in my word? So we have 1 negative. Oh man, please. I especially hate when it does it at the end of the class, when you don't have much time anyway. Okay, save and copy. Save. Go, 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 go. Sorry, guys. Come on. So do all of you have determinant 26? Is there anybody who doesn't have determinant 26? Ahmed has 26. Anyone else? I guess most of you didn't do that. I'm assuming. Come on, do the loading fast. Oh. Can I write now? 1 negative. You know what? Let me close it and this is getting annoying. Sometimes I think about technology. The way everything is getting, humans are getting removed from most of the things, and technology is coming in. For example, Amazon. Less human transaction, more technical transaction. What if our technology broke down? Then what happens? That would be a good lesson for everyone who is relying too much on technology, like me. Did you notice almost most of the class, not in every class, in most of the class, my computer does something weird. Few days ago, I was teaching at Baruch, and then in the middle of the class, someone is controlling my computer. I had no idea how it was happening. I got so scared. -26 or -26? It does matter actually. The sign does matter. I just forgot which one, 26 or -26. Oh, I went too far. Okay. I hope it drops now. One, -4, 3, -2, 1, 2. Our main diagonals are -1, 0, and 3 times 4, 12 times 2, negative 24. So we have negative 1 plus 0 minus 24. And you're subtracting the entire diagonal, which is 3 times 3, 9. Then we have 0. And then we have 4 times 2, 8. Negative 8. So we have minus 9, minus 0, minus 8. Oh no, minus turn into plus. Right? 1, 1, negative 1, 0. 4 times 3, 24 negative. And then 3 times 3, 9, negative 0. And then we have negative 8, so times the positive 8. So we get minus 10 minus 16. That gives us negative 26. Yep, our determinant is negative 26. And then what did you do? Mohammed.
Then I extended that matrix. So the next I did, I wrote 1 minus 2, 3.
1 minus 3. How do you get 1 minus 3?
Oh, sorry, 1 minus 2, 3. Sorry.
Oh, so this one. 1 minus 2, 3. 1 negative 2. 3,
Then
2, negative 1. 3, 2. So cross out this. Let me write this little bit below.
Question. Wouldn't that be negative 4, 1, 0?
Huh?
The next line wouldn't be that negative 4, 1, 0?
Negative
Third,
4.
yeah, the last row.
Exactly. Why I keep writing all these wrong things? Come on. Thank you. We have negative 4, 1, 0. Negative 4, 1. Yep. So 1 over negative 26. Another new matrix. What do you have for the new matrix?
So 1 times negative 1, then 2 times 0 is negative 1.
Mm-hmm.
Then 2 times 3.
And where did you write it? On the row or on the column?
On the row.
And then 6 minus?
2.
2. That gives us 4. And then?
Then negative 2 times 0, which is 0, minus 3.
So that gives us negative 3.
We're done with that.
You start with the second and third row.
Yes, I think after that I messed it up my work.
So you always start with the first column, first 2 columns. And then you ignore the first column, you take the next 2 columns. And then you ignore the second column and you start with the next 2 columns. So first, the first 2 columns, then column 2 and column 3, and then lastly column 3 and column 4. So would you like to keep going?
No, thank you.
Anyone else would like to try column 2 and column 3? Give me all the determinants for every 2 by 2 minor or cofactor. Volunteer. Are you guys feeling lazy today? Crystal, thank you. Go ahead.
Okay, I by accidentally got a different determinant because I added something wrong, but I could do these the determinants for the rest of the matrix. So 0 minus 4 is equal to -4.
0 minus 4 is -4.
And then -1 minus 9 is equal to -10.
-1 minus 9 is -10.
And then -12 minus 0 is -12.
-12 minus 0 is -12. Thank you. And now the last
And
two
then
columns.
-8 minus 3 is equal to -11.
-8 minus 3 is -11.
And then -6 minus 2 is -8.
-8.
And then 1 minus 8 is -7.
1 minus 8 is -7. Thank you. So that means our inverse, we divide every element by our determinant. So -1 over -26, 4 over 26, -3 over 26, -4 over 26, -10 over 26, -12 over 26, negative, oh, sorry, negative, 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 -11 over -26, -8 over -26, -7 over -26. So the final answer is 1 over 26 positive. 4 and 26 both are even numbers, so we get -2 over 13. Then we get positive 3 over 26, -2 over, or negative turn to positive. Positive. So everything is negative except 1. 6 minus 2. Yeah. So we have 10 and 26, that gives us 5. 5 over 13. 12, 26 gives us 6 over 13. 11 over 26. 8 gives us 4 over 13. And lastly, 7 over 26. It's a horrible looking one. But in the exam, I'm going to give you something nice looking. Not this horrible looking one. Any question? -1, 4, -3, -4, -10, -12, -11, -11. Yep, our answer is perfect. With this, we are done with section 2.1. So your homework 2.1, it's due, it will be not next week Monday, but next week Wednesday, which is 9/11. Oh, sorry, 3/11. And the questions, I'm going to post them on Brightspace. But 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 questions. Today is 3/11. Yeah. So it will be 1 week from today. Did I say 11? I said 18, right? Let me see. Something is wrong with me today. See? I meant 18. Yeah, it's 1 week from today on 18th, not 11. Thank you for catching the mistake like last time, guys. Okay, with this, we are done with today's class. In our next class, we are going to do more on determinants. We are going to talk about determinants for 4x4 and beyond 4x4, but we're not going to find those determinants. We need to find the determinants only for 4x4. And then what else we have? Some proof, some more finding determinants, and we will be done. So we will be done 2.2 in our next class. And next Monday, I might have to cancel the class. Okay, I'll let you know on Sunday if I have to cancel it or not. If I do have to cancel it, then I'm going to send an announcement. So please keep an eye on Brightspace or in your email. Okay. So goodbye, everyone. Have a good day. Enjoy the bright sunny day outside. Bye-bye.